Hey, what's up? This is Mark at alchemist.camp, where we learn Elixir and Phoenix by building things. This episode is about improving Phoenix's already very formidable performance by using something called ETS. Last time we did some very basic Phoenix performance tuning and got it to where our homepage could support 1,200 requests per second, which is pretty crazy because this is a $5 a month DigitalOcean droplet. This time we're going to look at a little bit harder of a task. As you can see, there really isn't too much going on the home page. There's one big image, but other than that, we're not asking much of the server. The episodes listing page, though, has nearly 100 episodes. It's got all of their titles, all of their links to YouTube. There's an associated entity which has information like how many views it's had, whether if it's restricted to premium users or not. And then there's a many-to-many relationship between that entity and all of these topics that you see over here. So we're loading a lot of stuff. We're hitting the database. It's nowhere near as performant as the home page is right now. We'll run a test and check that in a second. Then we also have single episode pages. So here's one example. Now at the top, each episode embeds a YouTube video, which is no work for our server, but there is a lot of content below it. All of this content is stored in the database. And in fact, there's a little bit of processing that happens to the content because of the way that I've made this CMS. I'll show you what it looks like when editing it. So I have a few macros like this that get expanded into links, and then the rest of it's basically an extended version of Markdown. So let's test out this page and see what kind of performance we have right now. And let's also test out the episode page. So we'll make a test using loader.io. This test is going to be for a single episode. I've already made a test like it before. We're going to be testing clients per second, and we'll send 150 clients a second. And I've found that if they make it 30 seconds, they pretty much always make it the entire duration. So we'll just test for 30 seconds, HTTPS, and I'll paste in this URL. There we go, and run the test. What this will do is loader.io will just send a bunch of traffic at the URL that I gave it on Alchemist Camp, and we'll see how well it performs. So this is the average response time. And we can see there are no timeouts, no failures so far, but it's not faring that well. We do have a load of 300 clients per second, and the average time to respond, this is the average time it takes for the response to get back to loader.io, is 6 seconds. And that's not very good at all. Okay, it did succeed though, so we'll do a slightly tweaked version. We'll try 200 clients a second. And all the other information is the same. I just skipped a bit of the simulation to save time. All right, so that's where we stand for single episodes. And for all the episodes, the episode listing, now let's look at the performance for the page with the listing of all the episodes. And once again, this will be clients per second. Oh, and that should be 30 seconds, not a full minute. All right, no errors, but it's 7.5 seconds per request. Not all that great. Now to fix that, here's our episode controller. There's a little bit of logic for which episodes are visible to who. Basically, only admins can see things that aren't published yet. The show page is what we need for the single episodes. And you can see we're getting this from the content context. And we're doing a little bit of logic on whether if it's premium or not, and then we're just rendering a show. And for index, we're rendering everything that's visible. So really all the logic we care about is going to be in the content. So get episode and list episode. So list episodes uses a helper that I wrote, which isn't really that complicated. In fact, I'll just zoom down there. We just grab the schema that I passed in, and in this case it's episode. It could also be an article or something else, and ordered by whatever constraint was passed in. If nothing was, it'll be ascending order based on when they were created, when they were inserted in the database. And then I preload the entity and the topics. All right, get episode has a little bit of logic to handle getting it by either the ID, which is a number, or by the slug, but it's really the same kind of deal. We're just getting it from the database, and then we're preloading the entities and the topics. There's a good guess that at least part of the reason why it's so much more work for our server to get a single episode or get the listing of all of them than it is to load the home page is just because of having to get all of this out of the database. Since episode pages are viewed all the time by users, but only changed by admins, let's cache them all in memory and then only load from the database if the episode isn't in memory already. So to do that, we're going to use something called ETS, which stands for Erlang Term Storage. And as you might guess, it's a gen server. So we'll go to our application and we'll add a worker. We'll call this worker campsite cache. And pass it no options. And this doesn't exist yet, so we'll have to make that file. Campsite.cache, and this is a gen server, so use gen server, and let's see, make a start link, and gen server dot start link. We'll name it for now. We'll call it camp cache, and that should be all we need there. All right. Then when we initialize the gen server, we need to create our ETS table there. So to do that, ETS, it's colon ETS, since this is an Erlang function, .new, and we have to give it two things. First is the name of the table, and second is the options. So we'll call this table episode cache. Later we might add another table called article cache or something like that. Then the options I'll give it are set, and this is the type of structure of the data. So you could have, say, a bag, for example, instead of a set, or you could have an ordered set. We're just going to use a normal set, so it'll be key values basically. It's going to be public. All processes can read and write to the table, and it's a named table. If we didn't make it a named table, we would have to store the PID that it returns and then use that PID to reference a table, and that's just more work. And then it's going to return OK and state. And we're not actually even using the state here. We're just going to have all the information we need stored in the table. This public API is only going to have three functions. It's going to have get, put, and delete. Get will get whatever data is stored under some key. Put will put some data under a key. And delete will delete a given key and the data that was stored under it. We'll start with delete, just to be alphabetical. And all we need is a key, and we'll use genserver.cast. Cast is because we don't need a response. Camp cache is the name of our gen server, and then we'll call it with a tuple, starting with delete and key. We'll have to match that tuple in a second. Actually, we'll just do that part right now. So internal API. To match the delete, we'll have a handle cast. And the key, and then the state, which automatically gets passed to it through gen server. So ets.delete. is how you delete a key, and we have to give it the name of the database and then the key. Since this is a cast, there's no reply, so no reply, and state, which once again we're not really using. So if we call campsite.cache.delete and pass it a key, it will call genserver.cast, passing this tuple. This tuple gets matched here, and then whatever that key was gets deleted with ets.delete. And we've just hard coded the episode cache in here for now. Later on, if we were say to add an article cache and a resources cache, maybe cache some other types of content on the site, then this would be more complex. Like we'd have to also pass in which table we're dealing with, and in the init we'd have to initialize more than one table. But for now, we'll just keep it as simple as possible and have everything work with the episode cache. All right, so after delete is get key, and here we're going to do a genserver.call because we do want to reply. And it's still camp cache is the name of the gen server, and get and the key. And we need to handle that call. And it's going to match on get and a key. As before, we don't really want to do anything with the state. There's one other argument that handle call gets, and that's going to be where it was made from. We don't care about that. From and state, and we can get something out of ETS with ets.lookup, and got to give it the table name and the key. Now it's possible they're going to pass in some key that's not valid. Let's actually take a look at that in IEX. ETS, okay, so we'll just make a new table just like we would in init right here. We'll do exactly that. So we have a new table, and now let's put something in it. Actually, let's get something that doesn't exist. ets.lookup, and we've got to pass in the name of the table, and then whatever key. So our key is going to be a ASDF, and we just got an empty list. Now what if there were an ASDF? Well, we can do that here. ets.insert episode cache ASDF. I believe we have to pass it in as a tuple. So ASDF and 1, 3, 5 is what we'll get. Okay, so now if we do an ETS lookup on the episode cache, here is the value that we had. So let's do a case here. We'll store it all in a reply. So we'll say reply equals case of whatever this lookup returns, and if we got an empty array, or an empty list I should say, return nil. And then when we do have something there, notice that the key is included in the response, and we don't really want that. Also, if we just had foo in there and we look it up, this is a keyword list, so that's actually a tuple. If we inspect that, you can see that's a keyword list. That's the same thing as a list with a tuple starting with ASDF and ending with foo. So in order to pattern match this, what we want to do is still be matching against a list, and it's going to be a tuple. The first part of the tuple is going to be the key, which we don't care about. The second part is going to be the episode. We're just going to return the episode out of that. Then finally, this function will return tuple with reply, and then reply, and this reply is whatever we got out of this case from the ETS lookup, and then finally the state. All right, one more left, and that's put. Put will take a key as well as data that will store that key, and then we'll call genserver.cast. Since put is another thing we don't need a response from, we're not getting any information, we're just putting it in. Camp cache, put, key, and data. And the internal API, we're going to need a handle cast for that put. And it's going to be a little bit similar to this handle cast we already have for delete, so we'll just copy that down. So we'll change this to put, and then we've got to add data to the function head, and instead of ets.delete, it's ets.insert, and once again we have key and data. And we reply, no reply, and state. That should actually be enough to do it. All right, after rebooting, we should be able to alias campsite.cache, cache.put, foo, give it the value of 42, and now we should be able to get that back out. Excellent. And cache.get of bar, instead of an error, it just says nil. Excellent. Cache.delete of foo. Now it's nil. Good. Let's try putting something in here again, and we can get it with cache.get. We should also be able to get it directly with ETS if we know the table name. And the name is episode cache. Excellent. All right, so we've got our basic key value store that is built in to our application now, or it's a sub application that starts up every time our app starts. Now that we have our key value store set up, let's go back to the context and change how these episodes work. So we're going to need to change list episodes, get episode, and update episode. We'll start with get episode. Our strategy will be pretty straightforward. Whenever get episode is called, we're going to check to see if it's in the cache. If it is, we'll just return that. If it's not, then we'll get it from the database using the same strategy we currently are. Every episode can be accessed both by its ID and by its slug, as it is now. So we'll actually just store 2 copies of each episode in the cache. We'll store the episode under its ID, and we'll also store it under its slug that goes in the title. That's because there aren't that many episodes, I mean, not really that many episodes, and they don't take up that much space. So let's start by making another function called get episode from database, and that'll take the parameter, and this one is actually going to be about the same as what we have up here right now. So I'll just drag this logic down here. Difference is we'll be storing this. So episode equals all of this. And then we're going to put that into the cache. So cache.put. And the key will just be the parameter that was passed in. So if someone looked for episode number 5, then this will go under the key 5. If they were looking for the episode threatened-chess, then it'll be stored under threatened-chess. Cache.put param, and then episode is what we pulled out of the database. So this will be the entire episode struct, and the rest of the application can interact with this exactly the same way as it would when we just got it out of the database and returned it. And since cache.put doesn't return anything, we need to return episode at the end of this. So that's how we get it from the database. Now, in general, when get episode is called, case cache.get param do. And remember that cache.get will return nil if this key doesn't exist inside the table. So we just need to look at whether if it returns an episode or not. We'll say episode. So this is going to pattern match for an episode struct. And if we get one, we just return it. And if we don't get an episode, I guess regardless or not whether if what we get is nil, if we don't get an episode, then we'll just call get episode from DB with the same param. And then this logic will do exactly what it used to do, except that we'll also put the episode in the cache. And that should be enough to test it in action. So let's look at the development version of the site. And we'll just get some episode. Let's see here. We'll get the awesome episode. Cache.get is undefined. Cache is not available. And that's because we have to alias it. So alias campsite.repo and also cache. Okay, we still loaded the episode. And let's look in IEX and see if we can do cache.get on awesome. We can, and it's the whole episode. And it looks like we've got the key in there too. But that's because it was the ets.lookup. So if we were to say my episode is equal to cache.get awesome, we've got all the stuff we wanted. So that's good for get episode. We've also got to change update episode. We've got to make sure that we put a new version of the episode into the cache every time we update it. Create doesn't have to change because the first time someone visits the episode, then it'll come out of the database and get put in the cache. So we're fine. All right, here's our update episode. And we can do basically the same approach. We can make an update episode 2db function. And you know what? That get episode would probably be from db. Oh yeah, it is from. All right, so update episode 2db. And this is going to be exactly identical. This is what we do to update an episode to the database. So the update episode function has got to call this one, and it's also got to update the cache. So we've got to make sure it works. So we'll say case update episode 2db with the episode and the attributes. If we have an OK and an episode, then we're good. And we put it in the cache. And the episode ID, and this is toString because whenever a request comes in through the controllers, it's going to be a string instead of a number. So we'll put the episode in the cache under its ID, and then we'll also put the episode in the cache under its slug. We don't need to string that because the slug is always going to be a string. After we put it in the cache under both its ID and under its slug, then we've got to return the response. And if there's a problem updating the episode, then whatever the error is, we'll just pass that back to the user. Okay, that should do the trick. Let's sign in there so I can edit the episode. And we'll change this awesome episode to start off with a smiley. All right. So after saving that, it should be updated both in the database and in the cache. Let's give that a check. So campsite.content.get episode from database. Awesome. And that has a smiley. Let's get one that has a smiley, and let's get it from the cache. Good deal. And make sure it was saved under 1. And once again, good deal, everything is updated. Then the last piece is listing the episodes. We'll use the same strategy as we just did. So first we'll check the cache for the episodes. And we will put them under the key episodes. And if they are there, now this is where it's a little bit different. It's going to return a list rather than returning a single episode. So we'll just match for a list. If we get a list of something back, we will call that episodes, and we will return those. And if we don't have a list, then something went horribly wrong, so we better get the episodes from the database. Episodes equals whatever this list function returned before, which is how we were getting them. And then we've got to put that in the cache, cache.put under the key episodes. And finally, we want to return episodes and end the case statement. This should work fine for listing all the episodes. We can actually make it a little bit simpler here. We'll just set the episodes inside the cache.put. Okay. Now we need a function to return only the episodes that are visible to non-admins. Remember, only admins can see the published ones. That's a super simple thing to do. Just make an episode specific function for it. List episodes published. And we'll list episodes and then filter that with enum.filter whether if its entity is published or not. And since entities are always preloaded, that should be fine. All right, let's go back to the site, make sure that the listing works. Make sure the listing works when we're logged out. And we should also have that inside the cache now. Cache.get episodes. And we do. And there are 3 of them. All right, this pretty much does what we need. I didn't add anything for delete because I don't really ever delete episodes, but if we wanted to, that would be trivial, just a single cache.delete and whichever key we needed deleted. So now that this is done, I'm going to go over to another tab. I'm going to commit this to Git, and then I'm going to use edeliver to build a release, and then deploy the release to production, and then restart production, and then I'll start recording again, and we'll look at the performance changes. The deploy is done. Everything seems to be working fine on the site, so let's give it a try. So before, our single episode pages were loading in almost 6 seconds, and that was at 150 clients a second, and they completely crashed at 200. Now we're loading at 200 clients a second, and it's actually a little bit faster than loading 150 clients a second was previously. So the cache is definitely a bit of a win here. That's a 33% increase in throughput. And the improvement on the listing page of all the episodes is even more stark. So previously, 200 clients a second was taking 7.5 seconds per load, and we improved that to 2.3 seconds. So that's more than 3 times as fast, and it could actually scale much further. I got it up to 275 clients per second for 30 seconds, and this is still loading significantly faster than it could at 200 a second previously. So in terms of the total number of requests that can be handled, so all in all, on the single episode page, we got about a 1/3 improvement, going from 150 clients a second to 200 clients a second. And on the listing page, we actually also got about a 1/3 improvement. We went from 200 to 275. So I guess 1/3 improvement would have been 266. So this was a bit better than that. And this page was loading dramatically faster, like almost twice as fast as it had been at the lower load before. And all of this is on a $5 a month DigitalOcean droplet. And if your busiest traffic in the day is, say, 30 times more traffic than you get on average, so maybe it's varying from like 0.3 to 30, so it's like a 100x range. If that's what your traffic looks like, you could serve tens of millions of visits per month at this level of performance, which is ridiculous. Far before that point, most people would upgrade to better than just the very cheapest offering. So obviously in this case, it was a completely unnecessary optimization, but still, it's interesting to see just how much you can squeeze from how little of a server when you're using Elixir and Phoenix. And for those of you who do have larger production apps, or you just want to be ready for the future, it's good to know that things like ETS are out there, so you don't necessarily have to reach for something external like Redis. If you've enjoyed this episode, then definitely subscribe on YouTube and click the bell so that you get more like it. And come to alchemist.camp itself and sign up with an email address and any password of your choosing for a free account, and you'll be able to navigate the site by topic and get a few other nice things. Until next time, code on.